In today's video, we're going to talk about Gauss sum. There's a famous story of this mathematician named Gauss, and he was given this problem by his teacher. I'm going to pause the video and you guys can try to solve it. So some people might try manually adding each number up, but you can find that if you add 1 plus 2 plus 3, etc., it takes a long time. So what Gauss noticed is that if you took the last number and the first number, it would equal to 101. And then if you did this again, it would also equal 101. So he noticed that the pairs of the numbers times the number of pairs would just give you the result. So if you did 101 times 50, you'd get 5050. So we can actually use this to derive a formula. So I'm going to go down a bit. Actually, I'll move off to the side here. And if we do S as the sum of all of them, and then instead of 100, let's set n equal to 100, which is the last number in the series. So we can do 1 plus 2 plus 3 all the way until n minus 2 plus n minus 1 plus n. And then we can write this in reverse as s equal n plus n minus 1 plus n minus 2 in decreasing order. So what you notice here is that if we added these up, this is n plus 1, this is also n plus 1, this is also n plus 1, this is also n plus 1, and this is also n plus 1, and this is also n plus 1. So what we get is 2s equals just n plus 1 a bunch of times. So the way we can actually write this out is we can write it as 2s equals n times n plus 1. So to simplify this, we want to just find s. So we can divide both equations by 2, and then we would just get s equals n times n plus 1 over 2. And we've derived a basic formula for Gauss summation. Okay, so I'm going to give you guys a practice problem, and you guys can try to solve it. Okay, so what you can notice here is that this gets added, and then it gets subtracted, gets 3 numbers gets added, and then it gets subtracted. So instead of just manually adding it, we can actually use the idea of Gauss summation that we just learned. So what we can do is that we can separate each of these into different kinds of equations. So let's just treat all the negative numbers as positive numbers. So let's notice that these are all multiples of 4. The numbers that get subtracted are multiples of 4. So it's just 4 plus 8 plus 12 plus 16, etc., all the way until 196 plus 200. Okay, so now let's look at the normal series. The normal series is just 1 plus 2 plus 3 plus 5 plus 6 plus 7. Basically, you're just adding it normally, except you're not including these numbers, and instead these get subtracted off. So let's actually just first find the sum of this. So what we can notice again is that there's a pattern with the pairs. This is equal to 204. This is also equal to 204. So how many pairs are there? Well, we know there's going to be 50 numbers in the series because the average, if we divide it, we would get 50. So we know there's 50 terms. So that means there's 25 total pairs. So 25 times what is the sum of one of these? This is 204. So this would be all of the numbers that equals a negative in the result. So if we multiplied all this out, 25 times 204, you would get 5,100. Now let's find the sum of the normal numbers. So I'm just going to treat it like a normal 1 plus 2 plus 3 plus 4 all the way until 200, and then we can subtract this off. So what would this be? This would be 201 times 100. And we can just evaluate this as 20100. Okay. Now we have overcounted because we have to remove this twice because we have to subtract this off. So we would do minus 10,200 because we want to multiply this by 2 because we're going to first subtract it because we're not including the 4s in here, and then we're also subtracting it again because they're negative. So then you would get 9,900. So this is your answer.